Hi guys, this is Vineet and I welcome you to this video. Today's video topic is temporal tables and this is part 4 of this video series. If you haven't watched the earlier 3 parts, I would highly recommend please go ahead and do so before you can continue with this part. And before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon. Select all notifications to get notifications regarding all my future and upcoming videos. So I'm giving you 5 seconds. Please go ahead and subscribe right away. I'm waiting guys. Please go ahead and quickly subscribe. So guys, I hope you must have subscribed by now. Let's move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. And we would like to know your thoughts regarding our video, so please do share in your comments, feedback and suggestions. We eagerly wait for your comments and would love to read the same. Guys, we have started T-SQL Bootcamp for you, which is basically 200 days of group coaching on SQL Server. And basically, we are inviting applications to enroll you into our Bootcamp series. And it's 200 days of group coaching. So any of the interested people can send in their applications via the below Google Forms link, which is given below. This is the link. And I'm also including this link in the video description area of this video. Once you fill out this form, we will send you the link to pay the coaching amount, which is the course fee for this course is 40,000 INR, and the period is 200 days for this course, which will approximately take like 10 months to cover up. So exactly it will be 200 days in which I will cover this material. Once I receive your application, if you are interested, I will send you the link to pay the course fee. So upon once you pay the course fee, we will send you the Google Meet link for whatever batch we are starting soon. So once you receive that link, you can start the batch at specific time. So let me show you the form, how you need to send the form. Let me open it for you. So this is the form, guys. Once you open that link, you will get this form. So it will be 200 classes or 200 days of group coaching, and we will cover 90 minutes each day. And following topics, we will start with getting started with select statements, and we will end up in the object and dependencies. And this course material will be covered during the span of 200 days. So we would like you to fill in this application form in case you are interested in joining this T-SQL Bootcamp for 200 days. Please fill in the required information, your name, email address, mobile number, occupation, and we have the following training slot preferences. Let me refresh this form and I will show you the time slots. So we have 3 time slots. First one is from 9:30 a.m. till 11 a.m. IST time. Second time slot is from 11 a.m. till 1 p.m. IST time. And third time slot will be a late time slot, which will cover 12 a.m. early morning till 1:30 a.m. in the night. So you may select your batch preference, like what time would you prefer for the batch? Do you want to join in 9:30 to 11 a.m. batch, or if you want to join 11 a.m. to 1 p.m. batch, you can select your batch accordingly, and you need to submit in the form. So once I receive your form, I will send you the payment link to make the payment for this course, and the payment for this course is 40,000 INR. So once you make that payment, I will send you the Google Meet link for the next batch we are starting. So we will take you into that batch, and you will receive a series of invites. All right, so yeah, that's it regarding this course. Let me know if you have any questions regarding this course. You can send me an email on my email address, which is vrmavnh@gmail.com. This is my address. You may note it down. If you have any queries related to this course, do send me your emails. I will try to answer your questions. There are some courses we have rolled out which you can opt for. So over the top, I have a topmate.io page which you can check for various kind of courses. I've listed out the courses as below. as well. But yeah, the same courses are available on my main page, which is the topmate.io page, topmate.io/vermavine. And you can also go to the below links directly to if you want to enroll for a particular course. So if you want to enroll for a SQL Server Coaching one-to-one session, and guys, these are all one-to-one sessions. So if you want to enroll for SQL Server Coaching one session, we charge 1500 for an hour if you want to learn about any particular topic. And second link is for the package of 30 sessions, which you can schedule as per your liking. When when it is suitable for you, you can schedule those 30 sessions individually. Third course is it's not actually a course. If you need guidance on where and how to start with SQL Server, you can have a 45-minute session with me, and for that we charge 500 INR, and this is the link. I have included all these links in the video description area, so please check it out. And guys, if you have any questions related to SQL Server, we charge 500 per question, 500 INR. This is the link which you can follow to post in your questions along with the payment, and yeah, we'll get back to you with the answer to the question as soon as possible. Right next, there's a link if you want to make us your partner in your learning. So in case you are learning some new technologies from other places, or if you are doing some self-study and if you want to discuss that technical content with us or discuss with us, then yeah, you can do so. And for that, we are charging 400 INR for an hour. So you can teach us your learnings as well in the technology. And this is my channel link page, not channel link page, but channel page. And let me take you there quickly. So this is my channel page. If you open that link, youtube.com/@master data science with Vineet, open that channel page link. So this is my channel having 766 subscribers at present, and we have posted 276 videos so far on this channel. And there are various sections on this channel page. So there are a few tabs: home, videos, playlist, community, and search tab. Using the search tab, you can search for any videos. So for example, if you want to search for backup videos, you can type in the term backup. Or for example, if you want to search for any videos related to temporal tables, which is the topic for today as well. So you can type temporal tables, type in enter, and it will list out all the videos related to temporal tables. So these are the earlier 3 parts that we have created, and this is the part 4 of this video series. So please watch out all these 3 parts before coming out to this part, which is part 4. Let's go to home section. So the home page is divided into various sections. So first section is for use section, where it list out the videos that are specifically as per your taste and likings. So it suggests you some videos as per your taste and likings. Second section is the video section, which basically lists out the videos in descending order of posted date. So this one is the recent video I had created on T-SQL Bootcamp. So you can watch that out separately as well. Also, I will include that video as a part of this video as well. So yeah, the last actual video which we had created on topic is create new media sets in SQL Server. So you can check out that as well. And the next section is on the popular videos, where you will see videos that are quite common on my channel, having more and more views. So these are some of my most common videos. And right next, there's a playlist section. So guys, the reason we create playlists for you is because we feel that playlists are best way to learn. If we talk about this video pertains to the SQL Server tables category. So we have a table playlist here, SQL Server tables. And apart from that, we have integration services playlist, performance tuning, indexes, database design, and business continuity playlist as well, having most of the videos. So if we talk about this video pertains to the SQL Server tables category. And if we take a look at the full playlist, so if you want to check the full playlist, you can click on this view full playlist button. So I was talking, the reason we create playlist for you is because we feel that playlist is a best way to learn. So for example, if you want to learn about the tables in general in SQL Server, if you want to know about table, or if you want to know about everything about tables, you can come to this playlist and watch out all the videos. So that is a better way to learn instead of watching videos randomly here and there on a particular topic. Yeah, it's better to learn about a particular domain. So if you want to learn about SQL Server tables, you can come out to this playlist. This playlist has currently 26 videos, and the best way to learn is to start with video number 1 and go till the end to watch out all the videos to gain better understanding and mastery in that particular area. And guys, in case you reach towards the end of the list and if you need more videos in that list, do let us know via your comments, or you can send me an email as well. I will add on more videos to that playlist. In case you have completed the whole playlist, do let us know about that. So let me come back, just go back to the channel page. So yeah, we are done with the channel page. This was our channel page. If you have not yet subscribed, you will find the subscribe link over here as well somewhere. So you can subscribe for my channel page as well. Click on the subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos, including the videos that I'm creating on the table section these days. So let me minimize this and come back. So this was regarding my channel page, and let's come back to today's topic. And guys, in case you want to send me an email, you can send me an email on this email address vermavana@gmail.com about any questions and any concerns. But yeah, some of the items are paid. You need to refer to this list if your question is falling under any of these category. If you are having some technical questions, then yeah, those are chargeable. But yeah, general questions I can answer free of cost. Alright, so today's topic is temporal table in SQL Server, and this is part 4 of this video series. So I think let's begin. We will start with demo, so this will this video will be totally practical, and we have to start from demo 8. In our earlier videos, we had covered till how to insert the data into table with the hidden period columns. Today we will cover how to insert data using a partition switch. So let me talk more about that, how to insert data using the partition switch. So in case your current table is partitioned, you can use the partition switch as an efficient mechanism to load data into an empty partition. Alright, so in order to do this practical, you must have a table that is partitioned. If your so we were talking, if your current table is partitioned, partition means we divide a table into multiple tables, right? So, or maybe multiple files. We divide a single table into multiple files as well. So in case your current table is partitioned, you can use the partition switch as an efficient mechanism to load into an empty partition or to load into multiple partitions in parallel. So the advantage of loading the data into multiple partition is you can parallelly load data into various partitions. Now the staging table, that is so if we talk about any staging table that is used in the partition switch in statement with a temporal table must have a system time period defined. So yeah, earlier we had shown you if you have to create a temporal table, you need to specify the valid from and valid to column, and you need to specify the period for system time clause to make it a partition table. If you are using any staging table with a partition switch statement with a temporal table, must have a system time period defined, but it doesn't need to be a temporal table. And this ensures that temporal consistency checks are performed during the data insert into the staging table. Alright, so basically adding the system time period clause basically ensures that temporal consistency checks are done during the data insert into the staging table, or when system time period is added to the pre-populated staging table. So let's move on to practical directly to show you what I'm talking about. So let's start with creating a table. Okay, we need to invoke SQL Server. So first what I will do, I will create a staging table with a period definition for switch in temporal table. Okay, so SQL Server is getting invoked. Alright, let's connect to the default instance of SQL Server. I need to write in some code. You can write that code along with me. Let's invoke a query against the MyAdventureWorks database. Let's invoke a new query. So I will be creating a new table here. In order to create a table, so first of all, let me tell you what I'm doing basically. So I am basically creating staging table with the period definition for switch in temporal table. Alright, so first of all we are creating a staging table with period definition for switch in temporal table. So let's begin with the create table definition. Create table, give the name of the table. So you can specify the schema if you would like to. So I'm creating a table dbo.staging underscore department underscore partition 2. This is the table name, and let's define some columns of this table. Let's create a opening and a closing braces. Alright, and let's define the structure of this table. So we will have a department ID column in this table, which is of integer type, and it will be a not null column. This is the first column. Second column will be the department name, and this is a varchar 50 column, and let's take it as not null. Third column is the manager ID, and again it's integer type with null, so this manager ID column can be null. And let's take parent department ID column, which will be of integer type, and this can take nulls. And let's define the valid2 and valid here we are creating a staging table, but we are not turning on the system versioning for this table for now. So let's take two columns, valid2 and valid from, to store the timestamps basically. And these are of date time type 2, and we need to take this column as generated always as row start. Alright, and these columns cannot be null. And similarly for second column, we need to specify generated always as row end. We need to specify that this should not accept any nulls, and we need to specify the period for clause. Let's define the period for clause. Period for, we take system time, and we pass on this valid2 and valid from columns, valid2 and valid from. Actually it's in reverse order, so we first specify valid from and then valid2. Alright, so this is the staging table we have defined with period definition. So this is a period definition, and basically we have given these 3 lines for a temporal table. So these items are required, so we have added these columns. This data will be inserted ultimately into a temporal table, so that's the reason we have taken these 3 columns. And let's move ahead. Now let's create a primary key, create aligned primary key. So let me create a code for you. So I need to alter this table which I'm creating. So table is this, and there's a staging table, and I'm adding a constraint which is a primary key constraint. Let's name this constraint state.department underscore partition 2 primary key. Alright, so take it as pk. To specify primary key, mention primary key, because this is a primary key constraint, and this should create a cluster index in the background. Whatever primary key you are creating, this should create a clustered key on the background, and that you can also specify on which column this clustered index should be created in the background. So it should be created in the department ID column, and you can specify the ordering of the index. It should be created in ascending order, and you can specify the file group as well. So I'm creating this index on the primary file group. So primary key clustered on primary. Alright, so let's first create this staging table quickly. Okay, I have specified the columns in incorrect order. So valid from column should come here, and valid to column should come here. So keep that in mind. Now this definition is correct, and I can execute the statement. So it is still giving me error. Temporal generated always column valid2 has invalid data type. So okay, the data time of this column should be date time type 2. I've omitted that. So I should be able to generate this table. So execute this table. So a staging table is now created. Let's create an index on the table for which we have written the code. Let's create the index on this table. So it is showing me that the index is some syntax is incorrect. So let me see why this is showing as incorrect. So I'm altering the table which I've created above, right? And I'm adding a constraint. I've defined the constraint name here, and this is a primary key constraint, and this is clustered. You can specify space after that. We are creating a cluster index on the department ID column, and the order of the index will be ascending. And I'm creating this. Okay, it is giving me some issue with this clause on primary at least. Okay, let's see if it takes this. So your primary keyword should be within the brackets, because otherwise it consider it as keyword. So let's execute. So here by primary I mean the primary file group. The index should be created on the primary file group, and otherwise if you take primary, take it as a primary key. So specify the primary keyword in brackets, and let's execute this statement. So this statement is executed and index is now created on the department ID column under this particular staging table. Now the third step would be so what we will do now is we will create and enforce constraints for partition boundaries. So here we will create partition boundaries, and here we are creating a constraints for the partition boundaries. And what else we will do? Partition 2 contains, so partition 2 will contain rows department ID greater than 100. So anything greater than 100 we go to the partition 2. And second constraint on this table is that it will also contains any row that are lesser than 200 or lesser than equal to 200. So 101 to 200 rows for the department ID values will be stored in partition 2. So here we are creating constraint for that. We need to alter the table again. So let's alter this table to add on these constraints. So alter table debug.staging underscore department underscore partition 2. Here we are adding a check constraint. So we are altering the table. We are adding a, so with check clause basically checks the existing data in the table to see if it satisfies the constraint that we are adding now. So you can specify the with check clause if this table contains any data. For now, I think the staging table is empty, so you can omit that as well. So what we are doing here is we are adding a constraint, and this is a check constraint, and let's name it as check staging. Yeah, this will be a check constraint. So we are checking the validity of the data. We have created check staging department partition 2 constraint, and this will be a check constraint. So specify check after that. Let's take it in next line. So this will be a check constraint, or I can take it in previous line as well. So let's start the bracket and define this check constraint on definition over here. So this check constraint, if we talk about, contain the department ID. This is the column. It should contain values greater than 100. It's an integer type column, right? Okay. So it should contain any values greater than 100. And second criteria is this partition can, we are just specifying the constraint on the particular table to see it should contains, for the department ID column should contains value between the range 101 and 200 or 100 and 200. So I've specified this constraint, so let's create a constraint quickly. So it's a constraint on the department column. So this constraint is now created. As a next step, what we will do now is let's alter this table again. So let's copy in the statement. Let me again alter this table. So far we have added the constraint, check constraint, and we can specify the, so let's execute this statement to apply the check constraint on the staging department partition to table, which is a staging table. So this is applied, and now let's insert data into table, this staging table. Okay guys, at this point what we need to do, we have added a check constraint to this particular staging table, right? Let's insert some data into this staging table. So we need to write the insert into statement and specify the name of the table. So we are adding some data into this staging table, and let's specify the column names to which we are adding the data. So we want to add data in specific columns, the department ID and the department name and the manager ID and the parent department ID. Let's add data into these 4 columns. So let's add in values 101 and let's take the department name as D101. So let's take department 101, and let's take one for the manager ID, and let's take null for the parent department ID. Alright, let's add in this data to the staging table. So what we are doing at this point is we are inserting, or we can say loading data into the staging table that we had created. Alright, so let's add the data into the staging table. So we have added the data, we have added one row. We can check out the staging table. Now it should have one row present inside it. So let's check the staging table. So we have the following data. Timestamps are created automatically. Let's add a partition switch now. So what we'll do now is we will use the partition switch in to efficiently add data current table. So I'm creating a partition switch. So guys, earlier we had created a table with the name dbo.department. So this was the, let's see whether it's a temporal table or not. So earlier we had created a department table in here. Let me show you the structure of that table. So we have this dbo.department table. I'm trying to locate this table, guys. So yeah, this is a temporal table that's as system version is mentioned against it. So you need to follow through the previous videos. If you have followed through the previous video, you must have created this temporal table. So this has the following structure. It has a history table as well. History.department is the history table, which contains the historical rows, and it has the following columns: department ID, department name, manager ID, parent department ID, and valid from valid to column. So system versioning is on for this table, but for staging table that we have created today, we have not turned on the system versioning because department is the table which is using the system versioning, but we do have added valid from valid to and period for system time clauses in this table. Now we have inserted one row of data into this table. This table has one row of data, and previously we had created this temporal table department. It has 3 rows, and if we talk about this table, it has one row at present, right? And let's use the partition switch in to efficiently add data to the current table. Let me take that below. So what we are doing now is we are using partition switch in to efficiently add data to the current table. So we need to alter the staging table. So let's alter the staging table. Give the name of the staging table, alright, which is a partition 2. And let's use the switch to clause, and let's take this table dbo.department after the switch to clause partition. Alright, so we have added this clause, we have added this table, the staging department partition 2 table. We have added the switch to clause. We are switching to department table partition 2. We have mentioned it like this. Now let's try to execute this statement to see if we can switch partition from a particular table. So here we are basically switching here what we are doing is we are doing a partition switch from a table, but without any period definition, right? Period definition is specified. So if you don't specify this period definition, you will get the error, but we have specified the period definition. So let's do a switch, partition switch from staging department partition to table. So it is saying that your statement has failed. So the error message is that your alter table switch statement failed, and it is saying the target table my adventure works DPO department must be empty. So this is the error message we are getting, and we can so I hope you are able to read this message. So I can type in this message above as well. So while executing the above statement, we got this error message. Let me comment these statements out. So this is the message we got: alter table switch statement failed. The target table my adventure works DPO department must be empty. So right now this table do have the data, so partition switching is not happening. Let me truncate this table to remove the data out of it. So let's do a truncate on the DBO department quickly to empty out this table. Alright, so let's do, instead of truncate, let's do delete from department, or maybe delete from dbo.department. Alright, so data is deleted. Now, right now this table does not have anything. You can check the table out. It contains nothing. Now let's try to do a partition switch here. Right, we are performing a partition switch. So this is done, but we got a warning: the specified partition 2 for the table was ignored in the alter table switch statement because the table is not partitioned. So although we have executed this statement, this particular table is not partitioned, but otherwise this is the syntax to turn on the partitioning, right? So the message is saying the specified partition 2 for the table. So in order for this thing to work, your dbo.department table should be partitioned. So this is basically for the partition tables. So for the department table is not partitioned, that's why this statement has ignored this statement altogether. So if your department table has a partition too, here what we are doing is we are altering this table and we are basically switching in data to the department table partition 2. Alright, so this will be a temporary staging table where data first goes in and ultimately goes into the partition 2 as per the check constraints. So yeah, that's it, and we are done with this demo. We were just trying to explain how to do the partition switching in case your table is partitioned, but in our case this table was not partitioned. We'll talk more about partitioning in our upcoming videos. So for now, let's ignore the code. Basically, I've mentioned this code just to give you a gist how to use the staging table and basically switching the data to the different partition of other table. Now let's move on to next demo. So demo 8 is done, how to insert data using a partition switch. Now let's do demo 9, how to update the current table. Earlier we had removed the data from the department table, right? Let me close that and bring in the new query. So we are doing the practical number or demo number 9. Here we will show you how to update the data in the current table, current temporal table, I would say. So you can update the data in the current table with a regular update statement. You can update data in the current table from the history table on the disaster scenario. So there are two facts regarding the update. So let me add in some theory over here. So there are some important points. You can update the data in the current table with a regular update statement. This is one item you can perform. And you also can update the data in the current table from the history table as well. So department table is the system version table, so it is keeping a history table for it as well. So we can update data from the history table into the current table for the disaster scenario. In case any disaster happens, we can update the values of the current table from the history table. However, you cannot update the period columns. So period columns, if we talk about, these cannot be updated, and we cannot directly update data in the history table as well. So history table cannot be updated while the system versioning is set to on. We cannot update the history table. Alright, so these are important lines, please make a note of this. Alright, now let's move on to practical how to update the current table. Let's switch to SQL Server. Now there is one more point I need to mention. So if you set the system versioning to off and update rows from the current and history table, so once the system versioning is off, you will be able to update the data in history table as well. So if the system versioning is off, the system will not preserve or does not preserve the history of changes. So in order to keep a track of history, your system versioning must be set to on, and if your system versioning is set to on, you cannot modify the data in the history table. Now let's move on to practical. We will show you how to update the current table. Now in this example, we will update the manager ID column. So let's see if we have any data in the department table, DBO department table, which is a system version table, right? So this is a system version table and it has the following columns. Let's see if we have data in this. So we have one row inside this department table, and let's try to update the data in this table. Let's use the update statement. Update dbo.department is the table name, and let's set the manager ID, which is currently set to 1. Let's set it to 5, or maybe set it to 501. And we are using the where clause where we are taking department ID 101. So let's take department ID equal 101. So wherever the department ID is 101, we are changing the manager ID to 501. So let's update this statement and check out the data. Now the update is performed, manager ID is now changed to 501. However, if we talk about these columns, valid from and valid to columns, these are period columns, we cannot update the period columns, and you cannot update the history table as well, as we discussed earlier. Now let's take an example where we are let's try to update the period column. This will generate the error. So let me try to update the period column. So let's set the valid from column, right? Let's set it to a particular date. Let me take this date and modify it to yesterday's date. Let's try to modify it. The system will give me error if I try to modify the valid from column, which is a period column. So I'm taking this, so department ID 101, I'm trying to change the valid from column. So executing this statement will give me the error. Let's try to see. So we got the error, cannot update generated always columns in table, sorry. So we cannot update the generated always columns in particular table. So these are generated columns, valid from and valid to, and we cannot update these columns. If we try to update this column, we will get this error, cannot update generated always columns in table, whatever your table name is. This demo is also done, guys. We are done with demo 9. Here we have shown you how to update the current table, and we have shown you cannot update the period columns which are valid from and valid to column. Now let's move on to next practical, where we will show you how to update the current table from the history table. So let's see if we have anything in the history table. So let's remove these statements. So department table has one row at present, and we have make modifications to this row, so the history table must contain something. So history table is history.department, so we can mention that history.department. Let's check what's there in the history table. So history table contains the information. So these 3 rows were deleted earlier. So history table now contains those rows. And this was the modification made. So earlier value was D101 with manager ID 1. We have changed it to 5, right? So let's execute both of them. So these first 3 rows were deleted and they went into the history table. And this is the modify operation that we performed on this current table. We changed the value of manager ID from 1 to 501. So history table is keeping track of that. Now at this point, if we feel that manager ID is not correct and if we have incorrectly applied the modification to the current table, what we can do is we can check the history table and update the current table from the history table. So you can use the update statement on the current table to revert the actual row state to the valid state at specific point in time in the past. And basically you can think of it as reverting to the last good known row version. Alright, so we would like to revert this row to this particular row, which was the historical row for this row. So in order to do that, let me show you a set of statement you need to execute. So we need to set the manager ID back to 1 from the history table. So whatever with the value, would like to update it from the history table. This is the previous version of this particular row, right? Let's try to update the data from the history table. So you need to use the update statement. You're updating the current table, which is the department table, and we are setting the department name. So we are also changing the department name here, although we had not changed the department name earlier, so it is same. We don't need to change the department name, but yeah, for a code sake, let's take history table and let's take department column, department name column, sorry. So his dot department name I'm taking, history dot department name I'm taking. We are doing an update from the table department from, no sorry, you need to specify the for clause for system time as of we can say 5:47 we can take. So this modification was performed at 5:58, right? So we can take any data before that 5:58. So we can take the data at 50 or 47 would be the correct time. We can take the data as of that time. So we will specify the exact date time. So 2024-08 and 29th is the date today, and let's take 5. This is by the way UTC time. Let's take 5:47 maybe. Let's take this time. whatever the data was at this time, I want to revert to that. So we want to update the manager ID because we had updated the manager ID, not the department name. So let's take manager ID over here, and let's take history dot manager ID. Let's see if this works. And we have specified the for system time clause to specify the exact point in time. And we have taken where history. And if we talk about this manager ID, we need to specify the exact table. So it's history.department.manager ID should be the exact column name. Manager IDs. Okay, so this is the correct syntax I think. Now let's take where history.department.department ID equal 101. We can take here history is the schema name, and this is the actual table name, and this is the column name. So let's take one more clause, and we are taking department.department ID 101. So we are trying to update the data where the department ID row has a specific department ID, and we are matching it with the history table same ID 101, and we are taking data as of time this, and we are setting the let's take department dot manager ID column, and we are updating it with the history dot department dot manager ID. Let's try to update execute this statement to see if it executes. It has given me that so what you need to do is as you're using history, so you don't need to specify this middle clause, so you can just take history. Similarly, you can take just history dot department ID over here. So let's execute this and see if this works. So it is also saying that okay, the multi-part identifier could not be bound. So you need to specify because here we have department table under the DBO schema as well as the history schema. So under two schemas, DBO schema and the history schema. So you need to specify the exact schema along with the table name whichever you're updating. So we are updating department, or you need to specify the exact dbo.department.manager ID. You are updating the value of this manager ID column under this table under this schema DBO with the history schema department table manager ID. Right, now this is the correct. Similarly, let's take this. Now this is correct. I think this should work. Let's still. So for specifically for history, you don't need to specify this. We are just taking a history, and you don't need to specify the table name along with it. You can just specify the column name. Let's try to see if it updates. So let's remove this. We are just updating the manager ID, so we can keep it like this. And we are updating it from the history.department.manager ID. And we need to take this as history. And yeah, you don't need to specify the table. Let's specify db.department.department ID equal to 101. So here what we have taken is we have taken system time as history. So at this point in time, whatever is the manager ID, it is taking that. And we are taking history.department ID as this. And second clause, it is giving me error with that. So let's just take the department ID. So this is the department ID of the department table. Let's see if I add the department clause, will it work? Yeah, it's working, and you can specify the, so it is not bounding, so let's ignore that, and let's try to execute this statement. It will update the, so it is again saying department ID is a ambiguous column, so I need to specify the exact column info. So let's try to execute this statement. It should execute now. So it is executed. All right, so here we have taken the for system time as of this particular time, and we have taken it as history, and whatever be the manager ID at that time at this particular time in history, that manager ID will get updated. Now let's check the row quickly. Let's match the data between the history and department table. Now see, the previous row has become history, and the history table, the current table is updated with this particular row. This is the current table. The row is updated from this row number 4, and the data is there as of this particular point in time. So this got updated. All right, and the previous data was added to the history table again. So this is how you perform the update. This is how you update the current table from the history table. Yeah, this is the code sample. You can make a copy of it. This is the statement you need to use to update the data. Let me move on to next practical, which is how you can delete the data. So how demo 10 is done, how to update the current table from the history table. So in our next video, we will cover how to delete data from the current and history table. We will talk about that. So stay in tune. If you have not yet subscribed, please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my future and upcoming videos, and also videos related to tables that I'm posting these days. In today's video, I have covered how you can update the current table, and we've also talked about how you can insert the data using the partitions, which we have shown you basically the syntax, although our table was not partitioned. But in case your table is partitioned, you can use that code. And after that, we have shown you how you can update the data in the current table, and then we have shown you how you can update the current table with the data from the history table. If you want to restore the data in a particular point of time, at a particular point of time, you can use this series of statements to do that. So all right, and this is where we have performed the matching on the history department ID with the department ID, and we have taken data system time, any particular system time in history, and we have updated the manager ID from the history table. And this is the syntax for that. Keep a note of that. And yeah, this is the last demo we have done. In our next video, we will cover the demo how to delete data from the current and history tables. So guys, we are done for today. I hope you liked the video, and there would be 2 or 3 more parts in regards to temporal tables. There is lots to cover. Today what we have covered is, we have already discussed about that. So we are doing temporal table these days, and this is the part 4 of this video series, and I think there would be 5 or 6 more parts to cover this topic completely. So stay in tune, watch out the previous 3 parts if you have not done so, and also watch this part. I hope you like this video. Click on the like button if you really like this video. The like button appears below this video. Click on that like button, and if you have not yet subscribed, there's a subscribe button near to that as well. Just below the video you will see the subscribe button. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my future and upcoming videos, including the videos I'm posting on the tables or temporal tables video series these days. And guys, do post in your comments, feedback and suggestions. We eagerly wait for your comments and would love to read the same. And also guys, if you have a good network of friends, please spread my channel among them, and you may ask them to subscribe to my channel. You can share my videos with them using the share button that come below each and every video. You can use that share button to share my videos with your friends over any of the social media platforms, and also ask your friends to subscribe to my channel. That would be very helpful. Thank you once again for your time on this video today, and you have a wonderful day ahead guys. Thank you.